As you may notice, this brings us into the Tickets tab, which we shall explore for the next several minutes. In this tab, you'll find a variety of views, search options, and tools to allow you to clearly focus and drill down into any area of interest. As you can see now, the focus is on data-related risk categories that apply to the ERP business application. As a side note, RecoverGuard keeps tracks of various potential risk categories, and you can select or narrow down the selection based off any of these. And it's not only useful here to search and retrieve tickets, but also for alerting and report customization. I'm just going to leave the selection as it is right now on data risks. So on the top of the screen, you will see a summary list of data-related risks for this business entity. And I'm going to click on one of them. So this brings up at the bottom part of the screen the ticket details. There's quite a lot of information you can drive out of a RecoverGuard ticket. And as we can see, we have several sub-tabs here. Begin with a description, basically what's the issue, and it will contain all the necessary information to reach out and fix the problem. Next is the business impact, and then instructions on how to resolve this particular issue. Some information about the history, and we can see this is a repeating problem in the data center. And finally, an area to preserve knowledge and comments. So we have also several controls for ticket manipulation and lifecycle management. I'm going to click our very first product button, and this is going to show up the topology. And basically, RecoverGuard will pick the most appropriate view to describe the problem. Now, this particular ticket shows us an incomplete replication. Notice how most of the storage devices are replicated, and probably were so from the creation of this particular volume group. And now a new device was added, but it has no replica. And you may notice that RecoverGuard has highlighted the offending device. The practical meaning is that from this point in time onward, we can no longer recover our data in the event of a disaster. Now let's move on to several more examples. I'm going to get back into the tickets module and select a new sample. We're going to review some more data protection risk samples as I introduce some more product capabilities. I'm going to use this filter tree at the left to switch context to the entire data center, not just the ERP business application. By the way, you can also do the narrowing down by focusing on individual sites, databases, or hosts. And so let's just take another example. This one is a relatively interesting one. I'm going to open the topology and then use the incremental view to tidy it up a bit. So this is a Hitachi storage environment. We have a Windows host which is using some SAN storage volumes. These are the volumes, by the way, and the host is totally unaware that there is a certain replication relationship that exists in between those two devices it uses to some other currently unallocated storage disks. Now, this puts the data of host Blake D at significant risk. Now, while it may seem a bit strange at the first glance, this is usually typical when you reclaim storage from an existing system and then at a later point in time start to use it again. And this is probably what happened here. Now, probably the storage admin did not pay notice to the fact that these two new devices have the burden of the replication dependencies that still exists. Sysadmin will definitely not suspect that, and so the system can work for a while with no particular problem. The risk here is that at a certain point in time, those two other devices, which I'm going to highlight, will get used by another system, and then storage admin may ask herself, well, why isn't the replication in use? And by putting it back to use, it will immediately corrupt the data of host Blake D, which is totally unsuspecting that this may happen, which will bring us to a complete data loss incident. Now, clearly, the easiest thing to do is just to dissolve the replication dependency between those two devices, as definitely there is no reason to keep that going on, and this will allow us to eliminate the risk altogether. So basically, our next example will involve an Oracle best practice violation that could lead to data loss. So I'm going to open the topology again, and I want to zoom in into the affected areas. I want to take a closer look at how the database looks like. I'm just zooming in. As we can see, RecoverGuard can show you the various subcomponents of a database. We have a database instance here, and we can see the placement of various components. So it's stored on 3 file systems. It's all neat, but in this case I want to expand it. And so now what we can see clearly is that our database files, I'm just going to highlight those, are stored on a file system which is in turn striped across 2 Symmetrix devices, which in turn have an elaborate replication structure involving a remote copy plus additional remote point-in-time copies. Now, so this part is perfectly taken care of, but if we take a closer look at the rest of the files, we'll notice that they have evidently being stored on a local storage device or directly attached storage, which practically means these portions do not have replica, which in turn means that the entire remote copy we have is totally unrecoverable. And so again, the phenomena of inadvertently mixing replicated SAN storage with local DAS is not altogether uncommon. In this case, again, the issue is about data loss. Let's move on to some availability-related risks, and I'm going to find those by choosing the category tree and then clearing up all the categories, but for availability issues, and search again. Now we should have a full view of those risks within the data center. And so let's just pick one such example, and as usual open the topology. And so what we see here is a NetApp environment, by the way, a NetApp SAN, and we have a 2-node cluster, System 1 and System 2. System 1 is the active one, currently activating a volume group, which is stored on those 4 SAN volumes, the one I've just highlighted. Now, what you can clearly see, and that's what the ticket states, is that the standby system is connected only to 3 of those devices. Here is 1, 2, and 3. It's practically not connected to the 4th volume, which is used by the volume group. Practically meaning that should System 1 fail, System 2 will try to go through the sequence of obtaining all the necessary resources. It will fail to mount the application volume group, and therefore instead of recovering within minutes, the system will stay down until manually addressed. Let's pick another example. Again, this one is in a clustering environment, and this is a rather simple issue. So what probably happened is that more storage was needed as part of the cluster, and a new cluster resource was configured to let the cluster know it should manage the new file systems. Now, there is also something you have to do manually once you create the resource and file system and so on, which is actually a relatively simple operation. You need to create a directory in each one of the nodes and the standby nodes, because otherwise it's really not possible to mount the file system. This is how Unix works. Now, because this is a manual operation, it may either get missed on one of the nodes, or even the slightest misspelling might result in the fact that one of the standby nodes cannot really complete the sequence of recovery should it be called to. And so this will probably remain hidden until there is a failure incident, and then your failover or switchover will not work, and then guess who is going to get a call in the middle of the night. And probably this could have been avoided by just running a scan using RecoverGuard. So to conclude our ticket introduction or ticket model introduction,